Welcome to 8th grade math. Today's lesson, this is 3.1 day 3. So 3.1 day 3, you should have a worksheet, not your spiral, that has these problems on it. So we're going to work on word problems. Hopefully you remember this from last year. And again, this is a little bit of a review. It is in chapter 3. These are not the exact same problems that are in chapter 3, however. So again, you can stop, pause, replay, watch it over and over as many times as you like to help you with this assignment. You're filling in each one of these examples, and I will be checking it tomorrow in class. Mr. Dunn is 6 times older than his daughter. I was always taught whatever at the end of the sentence, that's the thing you know least about. That's what you make the X. So let X equal the daughter. Remember let statements from last year? Or, remember from last year, I could bar model this. So I could say the daughter is a bar. Mr. Dunn is 6 times older than his daughter. So Mr. Dunn is 6x. And yes, if I wanted to bar model this, I could make 6 parts of this bar representing Mr. Dunn. 1, 2, 3, 4, 5, 6. And their difference, so the difference in my bar model would be 5 boxes, or the difference, if I was writing it algebraically, the difference of their ages. So Mr. Dunn, always a larger number comes first when you do difference, minus the daughter equals 50 years. I'm not sure this is an actual true statement, which it's not now that I look at the answer. So the difference in their ages is 50 years. Find the age of each. So like terms problem, 5x would be the subtraction. 5 boxes or 5 units would be the subtraction in the Singapore method to draw it if I wanted to draw it out. So 5x equals 50 dividing by 5. I get x equals 10. I am not done, not done, not done. I've only solved for the daughter, the x, one of the let statements. I've only solved that one. You need to make sure that you're solving both let statements. So 6 times my x would make Mr. Dunn 60. He's not quite there yet. So find the age of each. Now, in Mrs. Agulia's class, I call it SABLE. S-A-B-L. Answer in a full sentence. Make sure you're answering the question that's being asked. Put a box around it and make sure you've got the label on it. In short, I call it SABLE. So yes, we are going to SABLE all of our word problems. So find the age of each. Mr. Dunn, capital letter there, Mr. Dunn is 60 years old. That's my label. And his daughter, his, H-I-S, his daughter is 10 years old. Put a period, put a box around it. That's the full algebra process. Mr. Dunn is 60 years old and his daughter is 10. Is their difference 50? Yes. The smaller number is, so example 2, the smaller number is 12 less than the larger number. Larger number comes at the end of the sentence. Let me erase these boxes here. Yes, I could do this in a bar model as well, and I'm going to choose not to. Let x equal the larger number. LGR for larger, number symbol. I can use the number symbol in my let statements, not in my full sentence answer, however, not in my SABLE. The smaller number is 12 less than the larger number. It is not 12 minus x. Be very careful. Less than. It is x minus 12. So let x minus 12 equal the smaller SM number. I can abbreviate in my let statements, not in my SABLE. Now, 4 times the larger number is the same as the smaller increased by 57. Find each number. 4 times the larger. Look at your let statement. 4 times larger, I called x. 4 times the larger, 4x is what it looks like to me, is the same as, that's the equal sign, so you'll see me write the big equal sign over the words, is the same as the smaller number, which I called x minus 12, increased by 57. So 4x is equal to x minus 12 plus 57. Find each number. Well, I've got like terms here. Negative 12 and 57 makes 45. So 4x equals x plus 45. My variable, I'm going to subtract x from both sides next. I get 3x equals 45. Dividing by 3, I get x equals 15. That's my larger number. Have to answer the second let statement. X minus 12, 15 minus 12 is 3. Find each number. So find some white space here to write my Sable. The numbers are 15 and 3. The numbers are 15 and 3. The smaller number is 12 less than the larger. Well, that's true. 4 times the larger one, which would be 60, is the same as the smaller number, 3 plus 57. That's 60. Should have made sure that made sense before I did my Sable. Next problem. Number 3. The perimeter of a rectangle is 72 centimeters. I always draw a rectangle to help me answer this question. Geometry, I always draw the picture. The width is 3 less than twice the length. The length is at the end of the sentence. It's my x. The width is 3 less than twice the length. So the length is x. Let x equal length. 3 less than twice, 2x is 3 less than. 3 less than means minus 3. So let 2x minus 3 equal the width. Now, the common mistake that students make is they just add a length and a width. The rectangle here reminds me that there are 2 lengths and 2 widths. This is a geometry question. Must have a formula. Perimeter of a rectangle is 2 lengths plus 2 widths. That also reminds me that I have to add 2 of these lengths, which I called x, so 2x. And 2 of the widths, oh, it's a quantity, 2x minus 3. That has to equal 72. So I plug that in. So now everything's been replaced in my formula. I've got distributive here. 2 times x, 2x. 2 times 2x, 4x. 2 times negative 3, negative 6. 72 equals 2x plus 4x minus 6. Like terms together, I have 6x minus 6. Adding 6 on both sides, I'm going to get canceling. Don't forget canceling. 78 is equal to 6x's. Dividing by 6, I get 13 is equal to x. Got to answer that second let statement. 2 times 13 is 26. 26 take away 3 is 23. So my length is 23. My width is, my length, strangely, is the 13. And my width is the 23. If I add those all up, 23 and 23, 46 and 26, 46 and 26, that is 72. Correct answer. Now I'm going to Sable it. Find the dimensions. And I could say the dimensions, or I could say the length is 13 centimeters. and the width is 23 centimeters. Or I could say the dimensions are 23 centimeters by 13 centimeters, or 13 by 23. Doesn't really matter that order. On number 4, one half of a number is increased by 20. The result is 35. Find the number. Oh, I'm only finding one thing here. One let statement. Let x equal number. I use the hashtag symbol there, which is really the number symbol. Those tweeters now using the hashtag. When one half of a number is increased by 20, so half of that x, I could write it 1/2 x, or I could write it x over 2, both ways, 1/2 x, 1/2 x, they both mean the same thing. I'm going to choose the half of x as x over 2. When half of a number is increased by 20, the result is, that's the equal sign, 35. Subtracting 20, I'm going to get that number divided by 2, or half of that number is equal to 15, multiplied by 2, and I get x is equal to 30. The number is 30. When half of a number is increased by 20, so half of it is 15, when I increase it by 20, yes, I do get 35. It checks. I'm not doing a full check. I'm mentally checking it, plugging it back in, and making sure it works. Find the number. And again, you can't use the hashtag or the pound sign or the number symbol. You have to write out the word the number is 30. Full sentence, answer, box, label. It's called SABLE. Sentence, answer, box, label. Next page. Pete has 5 times as many marbles as Kyle. I could draw 1 bar for Kyle and 5 bars for Pete. I could bar model this. Jack has 3 less than 4 times Kyle. Both Jack and Pete are being compared to Kyle. Guess what? Kyle's the x. Let x equal Kyle. Together they have 167 marbles. So Pete and Kyle and Jack all together have 167. How many marbles does each boy have? Well, I know Kyle has x. Pete has 5 times as many as Kyle. So he has Kyle's x, 5x. Let 5x equal Pete. Jack has 3 less than 4 times Kyle. Kyle's the x. Jack has 3 less than 4 times Kyle. Kyle's the x. So 4x minus 3, that's Jack. All together, they have 167 marbles. So x plus 5x, Kyle plus Pete plus Jack, 4x minus 3 has to equal 167. Putting my like terms together, I get 10x minus 3 equals 167. Adding 3, I'm going to get 170. 10x is 170. Dividing by 10, x equals 17. 5 times 17 is 85. And 4 times 17 is 68 minus 3, so that's 65. 4x minus 3 equals 65. Pete has 5 times as many marbles as Kyle. Okay, so 17 and 85, that works. Jack has 3 less than 4 times Kyle. Kyle is the 4 times 17, I already did that. He has 65. Altogether, they have 167. Let's add these 3 numbers together. 5 and 5 is 10, and 7 makes 1. Carry the 11, makes 17. Carry the 1, not the 11. 1 and 1 is 2, and 10 and 6 is 167. Yippee, they do add to 167. So that looks pretty good to me. How many marbles does each boy have? So, I'm going to have to squeeze it over here. Pete is the 5x, so Pete has 85. I don't know why I wrote him first, but it doesn't matter. Kyle has 17. and Jack has 65 marbles. I didn't want to write marbles every time. Has 65 marbles just because I'm running out of space here. But that is the label. The label is marbles. I'm going to put a box around my answer. And it is in a full sentence, capital letter at the beginning, period at the end. That's a literacy requirement by New York State Common Core. The larger number is 1 more than twice the smaller number. 3 times the larger number is the same as 5 times the smaller, increased by 10. Find each number. Woo! The larger number is, I know something about the larger number. 1 more than twice the smaller. Don't know the smaller? That's the x. Let x equal smaller number. Small hashtag. The larger number is 1 more than twice. So let 2x plus 1 equal the larger hashtag. 3 times the larger is the same as 3 times the larger is the same as 5 times the smaller, increased by 10. Find each number. Well, I'm going to leave it right there, folks. That's going to be up for you to finish on your own, and I'm going to check that question, number 6, when we come together tomorrow. So that's it for today.